Hi, and welcome to our August 2022 Lexicon webinar. We've got a great turnout today and are very happy to have you here. My name is Thomas Burley. I've been a delivery lead at Lexicon for 3 years and will be your moderator today. I'll briefly go through our agenda now. We've got 2 presentations today for you, which will run approximately for 15 minutes each, and we'll have times for questions and answers afterwards, so please feel free to submit those through the Q&A button at the bottom of your screen. For any of you who need to drop off, please feel free to have a look at our LinkedIn and social medias after, and we'll be sharing the presentation. Also, if you'd like to share it with any of your friends. And just finally, happy to take some feedback. So if you have any questions or comments or feedback for us, please feel free to email mailise@lexicon.com.au at any time after the presentation. Let me introduce our first speaker. I'll now introduce Dan. Dan's a tech principal at Lexicon and loves to snowboard in his free time. I know he's passionate about building quality throughout and making sure that we have confidence to release. So I'll hand over to you, Dan. Welcome.
Beauty, thanks so much. I'll just share my screen. So today I'm going to be talking about code coverage, 100% code coverage, and other myths that we tell ourselves. There's quite a lot that I'm going to be covering in a fairly short amount of time. So sorry, I'm not going to be getting into too much detail, but hopefully it gives you a good overview of some of the different ways that we can build confidence and tell ourselves the right things as we're doing it. Can you see my screen, Thomas?
All good from my end.
Beauty, sweet. So 100% code coverage. I think there's a lie here, but that there's specifically a lie in each one of these words. It's one of the things that we sometimes tell ourselves that we've got, give ourselves a nice little pat on the back for having 100% code coverage, but it's not always true. And maybe it's not always something that we actually even want to go after anyway. So as we go through this talk, I'm going to go through each one of these words and kind of expose some of the myths through each word. So the first one is coverage. What actually is coverage? There's a few different metrics for measuring coverage. Some are more popular than others. The first one is line coverage. So this is simply checking to see each one of your lines of code, and then when you're running through a test, does each line of code get executed or not? So in this example here, we're checking to see what we're doing today. Of course, it's going to be to go jellyfishing, but you can see that the go to work line of code hasn't been executed because this test only tests what happens on a Monday. So we've got line coverage for lines 1 to 3, but no line coverage for line 5. This is probably the most common form of code coverage. And generally, when you hear the word code coverage, it's referring to line coverage. Another one that's similar is branch coverage. So in the same test, we can see that little E there in our coverage report. That means that the else statement isn't checked. So we don't have a case here where the day of the week doesn't end with day. And so we don't get the branch coverage for that. So the line 5 line coverage is not checked, but similarly, the 2 branches that we have are not checked. So one of those branches is where the day of the week does end with day, but the other branch where the day of the week doesn't end with day is not. And so it's reported that we've got 50% branch coverage here. I'd say this is probably the second most common form of code coverage, probably a little bit better than line coverage, just to make sure that you're actually covering all the branches of your code and making sure you're checking all of your edge cases, because there can be some sneaky ones in your if statements sometimes. Another one I hear a lot, especially from UI automation or from managers especially, is what is your coverage of your features, or what's your coverage of your automation? Automation being used as a drop-in for UI tests usually. This one is a lot harder to track. I kind of find the coverage metric here is very wishy-washy. Usually it's just pick X number of major features in your app or your service, and then have you got a test for that, yes or no, and then the percentage of those is your coverage. This is not, I think, a great metric, but I think it's a good tool to kind of understand what you're covering and what you're not. I think most of your edge cases should really be covered in the previous kinds of tests and unit tests, but you can still get a bit of an understanding for what you're testing outside of your unit tests with this metric. And I would say this is less of a number metric and more of a yes or no. Have we covered enough or have we not? The next one that I don't hear talked about at all is assertion coverage. So this is kind of one that I've just made up, but it's how many assertions do you have per line of code, or like assertions per minute in your tests. A unit test that has no assertions will give you line coverage and branch coverage. In this case, I've commented out the assertion in the same test. So now we're not expecting to go jellyfishing, we're just running the code. We still get 100% line coverage, we still get our 50% branch coverage, but we don't get any value out of this test. If we changed the code, this test would still pass, and we'd basically be falling asleep with our alarm turned off. Some tools, like we can see here, I've got my linter telling me that this test has no assertions, and it's giving me a really big warning over the test, which is great, but not all tools do this. And it doesn't tell you, even if you do have an assertion in there, whether that assertion is actually doing something useful for us. So really, I think there should be an assertion for each specific line of code. So one to talk about going jellyfishing, one to talk about going to work, and then one to kind of figure out, are we on the right day of the week or not? So put heaps and heaps of assertions in your tests, and do make sure that those assertions are specific to what you want to actually test. One thing I do that is a TDD flavor. I must admit, I don't always practice TDD, but one thing I do like to do from TDD is to make sure that any test that I write, I watch it go red. So if you can write a test and then change your code to make the test fail, that's a good indication that your test is doing a good job. Any test that never fails provides zero value, and you should delete it. So the next thing in the 100% code coverage is the word code. Are we always testing the code? So previously in the line coverage and branch coverage, I might have written a heap of unit tests. My code is fully tested. I'm very proud. I'm very happy with that. But there's a bunch of things that I've missed out with those unit tests, and that's testing infrastructure, network, different integrations, non-functional requirements. There's different aspects to our software that we need to consider outside of just code and unit tests. So in the Krabby Patty example, the Krabby Patty is the code, the burger itself, but what we haven't considered is how clean is the restaurant, how good is the service, how quick is the service. So a few of these examples are like config changes. Some people consider config code, some people don't. I think that any change to config has got the opportunity to fail or to break your software and cause a regression. So anytime you change config, I think you should be running some kind of a test. I think those tests are similar to an infrastructure test. Any kind of infrastructure change also could break your system, cause regressions. There are pretty common ways to test your infrastructure. So your RAM, your CPU, your disk, you can add monitoring to all those things. And also, if you're using infrastructure as code, you can check that your configuration is accurate. So like a Terraform validate will tell you if your Terraform is correct or not. But I think the best way to really test your infrastructure and test your config is to have a functional end-to-end business flow or a smoke test, so that once one of these changes has happened, you can run that smoke test over your business, your key business flow. And if it passes or if it doesn't pass, you'll know generally that your infrastructure has broken something. Your unit tests will have caught all of your edge cases before making any of these changes. So hopefully you've covered edge cases in your unit tests, but any infrastructure test can still have that end-to-end smoke test. And then you can use those smoke tests to act as kind of a monitor that's ongoing. So you can run that every 15 minutes and wake somebody up in the middle of the night if anything goes wrong with one of those tests. What about when we have another team involved? So our software never operates in a vacuum. Generally, we're calling other services or other services are calling us. So how do we know that our app plays well with others? That there are different ways to do this. Some are easier than others. If you're in a really big enterprise environment, it can be pretty hard to do a full end-to-end test across the entire stack if there's like a mainframe involved. So often we resort to a boundary test where we stub out certain parts of the flow, but not others. This does come with some disadvantages as well. Like, how do we know exactly what the other team is using our code for and how they're using it? We're not really sure how people use our work. So we do make assumptions and test against those assumptions. I think one tool that we can have that lets us validate those assumptions is something like pack testing, where we test against the contract. The contract is essentially a stub, but we're using that same contract for another team to test with. So we're always validating whether the stub that we've got is actually the right assumption. If the stub's not the right assumption, then we can change the stub or the contract. Finally, there's non-functional testing. So this covers quite a broad range of things that you could be testing. So security scans, accessibility scans, usability tests might be with real people. I don't know how easy that one is to automate, but and performance testing. Netflix does a lot with recoverability when they have their chaos monkey. So they'll take down servers in production and make sure that things are recovering well. That's the way that they test their recoverability. So there's lots and lots of different things that we can test outside of just the code. And we can map them out. So we can put them onto a bit of a map to see what are all the things that we're doing to build confidence in our software. Unit tests are just one part of that. But if we draw some lines on that picture, really we've just got a CI/CD pipeline. So hopefully most of these things are automatable, and any change that you make to your code, you can run through all of these things, and you've got yourself a CI/CD pipeline, and you can practice continuous delivery. Cool. The final one is 100%. So I think this is the biggest myth, that the word 100% actually means anything. So can we really test everything in our code, even if we're just talking about the code itself? I'm not sure that we can. What do we consider testable code? So in some applications, certain code is not really unit testable. Mobile apps, I think, are a good example of this, where the UI is really difficult to test, or there's some native device functionality like GPS that we need to unit test. There's other things like database transactions that a lot of people say that it's hard to test, but I think in some ways it can be tested in unit tests. You just need to be a little bit more creative with how you set them up. A lot of people use fakes or stubs or mocks to bypass that untestable code. I think that's good as long as you find another way to test that functionality somewhere else. So if you're mocking out your network layer in your unit tests, then I would definitely have one of those end-to-end tests that actually checks to see that things are talking to each other at some point in your CI pipeline. So we might not be able to test things in unit tests, but there should be a way to test things. This is where I kind of turn to clean architecture a little bit. This is a good way to separate your core business logic from all of the integration points to your software. So usually this is implemented because it's really, really easy to test or unit test anything in that domain layer, which is generally your pure business logic. So if you have an acceptance criteria or a requirement, usually you can write a test that 100% mirrors that requirement in the domain layer. Ideally, you're testing the behavior and not the implementation of that layer. What that means is generally your tests should hit the public interface to that domain or to that layer of the clean architecture, and stub out any other layer, but not stub out private things within that layer. So generally, you should be able to change any private method without changing any of your tests or breaking any of your tests, unless, of course, you've actually broken some code. So I think getting that interface right and testing that interface is really key. And mocking against that interface is really the main place where you should mock. Building mocks on private methods, I think, is a dangerous pattern you can get yourself into, and it will make any change that you make to your code very, very tedious and painful without actually even giving you that much confidence that your code's doing what you want. A lot of people with clean architecture will say that certain things are not testable, and they'll provide coverage exclusions. So let's say I provide a coverage exclusion to all the code that interfaces with my UI, my database, and the device. Now I've got 100% code coverage. I'm not actually sure that that's 100%, but we often tell ourselves that it is. If we actually got a real number out of this, would this be 80? Is this an acceptable number? Would this be 50? I think it depends on how much code is in your service and in the different parts of these layers. But again, if you're going to be doing this and providing this exclusion, I think it's good to test these things in other ways in other parts of your CI pipeline. Cool. So what can we take from all of this? I think don't trust the number is the biggest thing that I want to convey. It's great to have lots of code coverage. I'm a big fan of having lots of tests, but I think the number 100% is a bit misleading. So have a look at the things that actually help you build confidence. That might not be a number, and some people might not like that you can't just put a number on that, but you should be able to communicate all the things that you're doing to increase the confidence of your changes. Be really intentional about what you're testing and where you're testing it. If you've got an end-to-end test or you've got a UI test, why is that UI test there? Is it there to test your UI, or is it there to test the integration to somebody else's thing? And make sure your tests break. If your tests don't break, then they don't provide any value. And when they do break, make sure you celebrate it, because you've just got a bug that didn't get to production. That's all I've got. Thank you very much. If you've got any questions, please put them in the webinar chat. I think Thomas will read them out one by one.
Great presentation. Thank you so much, Dan. We've got a few that have come through, but I would encourage everybody to add some more because we've got some time before our next presentation. So I'll just set these to answered and answering online. So you might need to flick over to the answered tab. But our first question is, what would you say to managers who ask a team to reach a certain code coverage percentage?
I would say, why do you want that code coverage percentage? I think it can be good to not have 0. A lot of teams pick 80 as a number, as kind of a finger in the air. Yeah, it really is just a finger in the air, but I think having 80 is better than having 0, because it means that you're actually writing tests. So I think not answering, I think there was another question in there, why measure it at all? You still need to measure it because you still need to make sure that you're writing some tests. So I think it's kind of a flawed number, but measuring it at all helps you get a kind of a finger in the air for, are we actually writing any tests or not? To really get at whether the value is there or not, I think you got to dig a little bit deeper, but I think it still provides some value, setting some kind of a target for the team.
So if a manager or somebody that wasn't on the team asked you for your opinion on what code coverage would be acceptable or what they should target, what would you start with that 80% in mind, or is there some other method that you would use to determine how much is enough?
I mean, I would say it's the wrong question to be asking, to be honest. Say, what are the other things that you're doing to build confidence in your changes, rather than what's that number? I think we should be measuring code coverage and failing pipelines if it goes below a certain percentage, but outside of that, I don't think we should be shouting it from the rooftops.
Great, thank you. Our next question. Should code coverage be included in integration tests? And what's the impact of including code coverage in the CI/CD pipeline?
I'm not sure what the second part of that question means. I think that the impact of including it in the CI/CD pipeline is kind of like what I said before. If you've got a small number, then that's a good indicator that you're not doing the right thing. So failing a pipeline if it goes below 80%, I think is totally fine. But you still don't know whether your tests are doing the right thing or not. Could they be included in integration tests? That's a pretty interesting question. Technically, it does cover your code, but again, I'd go back to your assertion coverage. What are those integration tests actually asserting, and what's the purpose of those tests? If they're testing something different to what you're testing in your unit tests, then sure, include the coverage. But again, I don't think we should get too hung up on the number itself.
Thank you for that. Our next question. Do you have any recommendations on duplication of assertions across multiple tests and keeping that duplicated code maintainable? Actually, something that I've had first-hand experience with in my teams. An example might be asserting that some common fields on a form display for each test case that is checking for uncommon fields in different scenarios. And I'll post the rest of the question in the chat.
Yeah, so I guess you're testing that common library is in use in a bunch of different places. Pretty good question. I don't have a one-size-fits-all answer to this, but generally what I would do is have a lot of tests for that common piece of code that go through every single edge case of whatever that library is doing. That is the place that you should be building confidence in whether that code is working or not. And then if you use that code everywhere else, just make sure that it's matching that interface, or it's actually calling that function. So I probably wouldn't go through all of the edge cases in all of the consumers of that library, but I would at least write one test to make sure that the library is in use. Generally, that's the way that I do it. Otherwise, you do get a bit of an explosion in tests.
Would you say, though, that it's probably better to have more duplication than less? Like if you're worried about adding a test because it may be duplicated, to add it first just to make sure that it is being tested? Or is that a dangerous path to go down?
In general, I think more coverage is better than less coverage. But as long as what you're testing is the behavior and not the implementation. So if you're testing an acceptance criteria and that's in a couple of different places, then sure. If you're testing that a private method calls another private method with a certain signature, then maybe that's less valuable. I also think a good separation of concerns means that this happens less, because you have one place in your code that does a certain thing, and that's its single responsibility. So any test that meets a certain acceptance criteria should only have one place in the code that you need to touch to change that. That's not always going to be exactly the case, but I think that's a good rule of thumb.
Makes sense. Thank you. Our next question is, can you give me some examples of tools that can help measure code coverage?
Yeah, I mean, it depends on what language you use. I've used Jarcoco a lot in the JVM world. Just out of the box, what we were just looking at, LCov is a pretty good tool. It really depends on what language you're using, to be honest. There are lots.
Thank you. Our next question, is there a good way to understand your assertion coverage?
Yeah, good question. No, not an automated way that I know of. I think this really comes down to in a pull request when you're reviewing code and you're reviewing your tests or reviewing somebody else's tests, just making sure that they cover all of the different variations that can happen in your code. This is a pretty hard heuristic to measure, I reckon, but really is probably in the review that is where you want to measure that. If anyone has any ideas of how to measure that one in an automated way, I'm all ears. I think that would solve a lot of our code coverage problems.
We've got time for one last question. What are some process steps that we could include to improve the quality of unit tests? Often I find people skip over unit tests when doing PRs, leading to poor tests. Any tricks on how we could rectify this?
I feel like that question was more talking about how do you stop people skipping reviewing tests when it's somebody else's test. That's a hard one, but I think a good process to writing good unit tests is to make sure that they break and to change your code, not your tests, and watch the test break. The same way that if you have a bug in production, say, you should write a test first that breaks and then fix the code and watch the test pass. I think that's probably the best way to get a good unit test. As far as reviewing other people's unit tests goes, that's a hard thing. You've just got to get good at reading through them and making sure that there is that arrange, act, assert pattern in the unit test. I also like to have good descriptions for my unit tests. So something human readable or something that matches the acceptance criteria is good because your test should really document the code. So I think getting into the habit of reading the tests before you read the code in a pull request is a good habit to get into.
Great, thank you so much for that, Dan. I might just reshare and introduce our next presenter.
Thank you.
Great, moving on to our second presentation for today. I'd like to introduce George. George will be working us through the world of state machines. He's been working on state machines daily for over a year now, and I can say personally was also a great partner in the amazing race event we had at Lexicon earlier this year. So really looking forward to this presentation, and welcome, George.
Hi, everyone. Let me just share my screen. Cool. So welcome everyone to my presentation on Rise of the State Machines. If you can't tell already from the image below, Rise of the Machines was a movie starring Arnold Schwarzenegger about the Terminator. So I made this presentation a little themed as an ode to that series. So this presentation is going to cover some of the basic features of a state machine, how you might use them in your project, and along with some basic tooling and a specific tool that I like to use. So let's get into it. So firstly, what is a state machine? A state machine is a way of representing an object or modeling an object, and it allows you to clearly understand the actions that it can take when it's in that specific state. So it's a relatively abstract concept, which is kind of intended. That means you can use it in different scenarios, whether it be like a micro, on a micro scale or on a large macro scale, where each state is something a lot more generic. It suits all of those use cases. And so a state machine is actually a subset of finite state automata. So I put a picture of finite state automata on the left there. Looks pretty confusing even to me, but that's a very mathematical approach to it. But if we break down the words of a finite state automata, the word finite alludes to the fact that there needs to be a pre-known number of states in the state machine. We can't have an infinite or an indefinite number of states. That it won't work. And a state itself can only be entered by transitioning from another state. And in that transition, it can give off some side effects, but yeah. And so an example of a state machine or a finite state automata is a Turing machine. I'm not sure if you've heard of that, but it's a sticker tape that takes in the current state and an input and moves back and forward along the sticker and across the process. So that's another example of finite state automata that you might have heard of. So how to explain a state machine? Traffic light's usually the easiest example. So here we can see a traffic light, at least where I'm from, a traffic light always goes from green to yellow to red. There's no way that a traffic light can ever go from green to red. And that's intentional. That ensures like safety, that ensures that it's used correctly. And yeah, you can easily model this as a state machine. So this here is a picture of a very oversimplified version of a state machine. We can see that we have a green state there and it transitions to the yellow state. Yellow state can transition to the red state and the red state can transition to the green state. And we see that there's no arrow or transition that's going directly from the green to the red state. That isn't possible within this state machine. But we're talking about the terminator here. So what would that look like as a state machine? Well, this is a very basic version of what the terminator might look like as a state machine. We can see the initial state on the left representing a black circle that's pointing towards the idle state. So in the idle state, the terminator might just be standing there, not doing too much, and that's the terminator's idle state. At the moment in this state machine, we only have one transition pointing to the final state, and we can see there's a trigger on that transition. And so the trigger is an event that may occur when in the idle state that causes the transition to be made. So in this situation, if you make the click off trigger or you have the click off event, the terminator will be turned off and reach its final state. And then so in the final state, the state machine's out of action, it's been finished, can't be acted upon at all unless it's reset. So I find it kind of funny that in this version of the state machine, the terminator could just easily be defeated by just, clicking off. If you're unfamiliar with the Terminator movies, in the second one, we have the Terminator, Arnold Schwarzenegger, on the right, and his task is to protect, his duty is to protect John Connor, who's on the left there. So how might that look as a state machine? Well, here we have on the left, we have the idle state, again, that's copied over from the past slide, but we also have some additional things. We have some triggers, which we saw, we have guards and actions. So at the moment, in this state machine, if we activate the protect human trigger, so if the terminator has been told to protect a human, it will attempt to get to the protecting target state seen on the right there. But we have a guard in place, which is in those square brackets. And so that guard says a human must have been previously assigned, or the human must be assigned to the terminator before he can protect it. And so this guard has to evaluate to true, so this transition will take place. If the human is not assigned, then the transition will not take place, and the terminator will remain in the idle state. And the slash there after the guard, it says relocate to human. So that's an action. So that's just the side effect of the transition. And so that will occur only if the transition goes ahead. So only if the guard evaluates to true. So a guard and an action are optional in the state machine, as we can see by the relieve duty transition just below it. That has neither a guard nor an action associated with it. So here we can transition the terminator from an idle state to a protecting target state, and then we can relieve him of his duty and go back to the idle state. What else can a terminator do? So the T1000, I believe, can transform into different people and disguise itself. So here we have the T1000 transforming from a woman into a police officer. So how might we model that in a state machine? Well, here we go. here we have the initial state as the disguised state, which is a bit different from the idle state that I showed earlier. But this one's a bit interesting. It has a transition which goes to itself. And this is called a self-transition. So self-transitions are possible and even necessary in certain types of state machines, such as like a Mealy state machine, if you're interested. But within this self-transition, an action can take place or other side effects can take place, which might be necessary within this state machine. So in this situation, we can go from the disguised substate the disguised state. The terminator can redisguise into the police officer, for example, and go back into that disguised state. And also I've included there the imitate speech state, so we can start speaking and stop speaking. And then we can also exit the disguise, which is the final state there. So this is a picture of my whole Terminator state machine that I put together all together. So we can see the protecting target state on the left. I've added an assigned human self-transition to the idle state. And on the right, we can also see the what's called a child state or a sub-state or a hierarchical state. And I've placed that in on the right there. So what we can do is we can contain a state machine. We can put one sub-state machine inside another state machine, which is really helpful for, I guess, keeping things segregated, not having everything in one location when it comes to coding it. And it also means that the exit disguised transition can occur from either the disguised state or the imitate speech state. So that's one of the advantages of having a child submachine. So how might we use or implement a state machine in our project? So on the front end, we can use state machines to ensure user interactions are intentional. And I'll go over this in some subsequent slides, but essentially it makes it so you only have to test transitions that are possible by users, and unintended actions don't really have to be tested, which is kind of neat. And it enforces certain states to the user. When using the backend, state machines can organize and which types of states are possible. We can have intentional segregation of information. We can also do some other cool things like ensure microservices have consistency by making sure we have one consistent state which all microservices retrieve information from. We can also use them to separate business logic from the code, which becomes really handy when talking to people with domain knowledge, but not necessarily much technical knowledge. So they can understand that code much more easily than without using state machine. They can understand the domain if they're familiar with they can understand the states if they're familiar with that domain. And lastly, embedded systems. They're commonly used just because actions are very specific in embedded systems, such as like clicking on a button or flicking a switch, or if you want to like turn on an LED. It's really well coupled to embedded systems if you want to use them in those situations, like with an Arduino or whatnot. So this image is, I guess, a mini state machine that I constructed just to make the point of what I was alluding to in the previous slide. So this image kind of represents how you might fetch an image of a terminator from the API. So we can see the initial state is the idle state. If we make a click, it'll go to the loading state. Now, from that loading state, we're fetching from the Terminator image API or whatever to try and get that image. But once we're in that loading state, what happens if the user clicks again on that retrieve Terminator image button? Well, since we're in the loading state and the loading state doesn't have a click transition, nothing will happen. If in another situation where you might not be using a state machine, if you repetitively click that button because you're really impatient to get your Terminator image, you might make multiple API calls, or you might get into a really difficult state that the developer didn't really intend you to be in. So by using state machines, we can make sure that only certain transitions are possible. And so, as I said, as we can see on the screen there, if you're in error state, you can't also click again. You can retry. It just makes it so things are a lot more manageable. So I'd like to now introduce some of the tooling, some interesting tooling. So this is what a state machine might look like in XState. So XState is a specific tool, one of the widely used tools for state machines in JavaScript or TypeScript. And this here is what a state machine, a bit of a simplified state machine, I've omitted some things for brevity, but it's what a state machine might look like for the Terminator, still using those same concepts that we explored earlier. So as we can see a couple of lines down, there's this thing called context that I want to point out. And that context is essentially like a state management or a state container, which is similar to something like Redux, where you can just put information in there and that information will be available to you in whichever state you're in. It doesn't really matter. So in this situation, I have the context. Within the context, I have a human assigned. Currently, there's no human assigned, so it's undefined. And there's a relocated to human Boolean there, which is set to false because the Terminator hasn't relocated to the human. Just want to zoom in a bit more now into this specific state. So this is how an idle state might look like. So when we're in the idle state, on represents some of the transitions that might happen. So on the protect human trigger there, the state machine will try and target the protecting state, which I've omitted from this image, but that's another state that's a state that it can transition to. And that COND, that condition there, is the same thing as what we looked at earlier as the guard. So this state machine will only transition unless the guard is fulfilled, which means a human is assigned. So in the situation that a human isn't assigned, the transition will not be made. But in the situation that a human is assigned, then the action down below will trigger. As we can see, there's an assign keyword, which allows you to mutate the XState context. And we're just assigning the relocated to human key to the value of true. So this is just like a small example of how you might create a state machine with code within XState. Cool. So I just wanted to compare as well some state containers, popular ones, XState versus Redux, which is a big question, and why you might choose to use XState over Redux. So firstly, a big one is the fact that XState is readily serializable. So you can create a JSON from it. So this is really big in the fact that you can actually store and retrieve JSON from multiple different locations. You can save it in local storage in case someone navigates away from your website and wants to come back. You can store it within a database, which is really good because it allows you to share it across microservices. You can use it in serverless architectures. So because you can just save it somewhere and then retrieve it later, and it's already in that state that you had transitioned to. So XState's really good for that. It prevents impossible states from occurring. So what we kind of looked at earlier, it means the app can't accidentally be in a loading and success and error state all at the same time. Whereas with something like Redux, if the developer isn't too clear on what they're doing, they can accidentally enter those states. Or if a user clicks the right combination of buttons, could be able to access those states all simultaneously. So XState really prevents you from doing that, which is a nice feature, given that it's a state machine. It encourages the use of nested states rather than having like a single atomic store that you might see with Redux. So having nested states encourages segregated state machines that might work independently or that may communicate with each other pretty easily. And lastly, the fact that Redux encourages this as well. And so this is taken from the Redux docs, where they recommend you use state machines, which something similar to a state machine or a state machine itself, which takes in the current state and uses the dispatched action in order to calculate the next state that it should go to. It shouldn't just take in the dispatched action by itself, which is possible to do in Redux. So just coming to the conclusion of my talk, I've done a bunch of state machine stuff in XState to prepare for this talk. This XState has some really good tools to help you with this. One of these is called the XState Visualizer. So I'll just click this link here to try and show you. So I hope that'll work and you can see my screen now. But on the right there, we have a large state machine that I've constructed for this presentation. I'm not going to go through all that, but on the left, we have the XState Visualizer. And so what can be done is you can click on those blue, whatever's blue on that screen, and you can walk through the state machine as if you were making those transitions, and you can see the possibilities of what you can and can't do. So this is really helpful, especially for people with no technical knowledge who don't really want to read the code, but are interested in, I guess, the domain that you're working in. So it's really good for people like that who just want to play around and actually understand what the code is doing. So I highly recommend, if you're using XState, to make use of this tool. So just going back to my presentation. And lastly, I have a link there to a basic use of a state machine in a React app that I created. XState has some awesome integrations with React and exposes some useful functions that can be used to easily use a state machine on the front end. So thank you very much for listening to my presentation on state machines. I hope you ended up learning something about state machines. If you like this talk and want to learn more, I highly recommend checking out this YouTube video by David Koshid, who is the creator of XState and he's an expert on it. And I also recommend checking out the XState docs, and you can find a bunch of useful features. You can see a bunch of the useful features that XState has that you can use on your next project. So lastly, I'd just like to say, as an ode to the Terminator, I will be back, and thank you.
Great presentation. Thank you, George. It makes me want to go and watch the Terminators again on the weekend. Some good memories there. We have time for a few questions. So as always, if you have any more, feel free to send them through in the Q&A bar on the left-hand side, and I'll put some of these in the answered as we go along. Starting off, probably a great segue from Dan's talk. What's the best way to test state machines?
Yeah, so there's a couple of different ways you can test state machines. The one that XState kind of recommends is to use something like black box testing, which, you take the current state and an input, and eventually you'll transition to a state later down the line, and you're just validating that you've eventually reached that later state. I find that with something like self transitions or things that depend on context a lot, it really struggles with that concept. So another thing that you can also do is use something like snapshot testing, which is really easy to use. You can just create a snapshot test whenever you want, but it also comes with all the other pitfalls of snapshot testing, where the developer might not know what they are testing and might, update it, and might not. There's just a bunch of pitfalls that come with snapshot testing. So I think you need to pick your battles, whether you want to use black box or whether you want to use snapshot testing. But in terms of black box testing, XState comes with some easy functions to make that, kind of simple.
Thank you for that. Our next question, can you describe some downfalls of using state machines?
Yeah, so interesting. So I think I alluded to this at the beginning of my talk, but coming to using it in a very macro sense, it's often difficult to have an idea of every state machine that might be transitioned to, or I should specify again, it's often difficult to have a finite number of state machines. Oftentimes you will have like an infinite number of states, which does make it difficult to create state machines out of things. On the micro side, I would say like it becomes really difficult to use state machines when they're too granular and the states and the transitions between them aren't well defined. It becomes difficult to isolate them from one another. It becomes difficult, I would say, for like other developers to come and like understand the state machines. It becomes difficult for like people who are new to the code. And it often becomes difficult when they're too micro scale to extend upon them. It might blow up into like hundreds of states, in which case you probably want to create a sub-machines out of those. But yeah, so when it's too fine-grained and there's too many of those states, it might become a bit difficult. So yeah, you definitely have to pick your battles.
Thank you. Our next question, are there any examples of programs that could not be easily created or represented with state machines?
Yeah, so I guess what I alluded to in the last question, it's something that has like an infinite amount of states. So like the amount of states unknown. Just trying to think of an example. Can't manage to think of one off the top of my head. I guess something, and as well as that, I think something which has like a minuscule amount of states, very minute. Yeah, like when there's like hundreds and hundreds of states, wouldn't recommend using it like that. Oftentimes, Redux would just be better, which you don't need to put things into states, and you can just put things in a store. So yeah, hopefully I answered that well enough.
Great, thank you for that. Next question, does Xstate support immutable state changes like Redux?
Immutable state changes. I'm not too sure, actually. I haven't delved quite deep into it, that deep into it just yet. I'm also not the biggest, haven't used Redux too much, so I'm not too sure. But I'm sure, if you go researching on that, you'll be able to find that out pretty quickly. Sorry about that. Haven't looked into it that much.
That's the joys of a live Q&A. Thank you so much for that, George. I might just reshare our final presentation and wrap up today's webinar.
Sure.
Great, just one final slide for me. I'd like to give a big thank you to all of our presenters and everybody for joining. We'll continue to host these webinars, so please connect with us on LinkedIn to stay in touch with us for future events. We live and breathe this work at Lexicon, so if today's topics interested you and if you'd like to learn more about what it's like to work here, please check out our careers page at lexicon.com.au/careers. And finally, for those that missed the introduction, if you'd like to rewatch any of this presentation or of our talks, a link will be available on our LinkedIn page shortly. So once again, would like to thank you all for joining, and we hope to see you soon.
Thanks, Thomas. Thank you, everyone.